Dr. Sirisha, working as Associate Professor in Institute of Aeronautical Engineering. Today we are going to discuss about double-ended queues and a small program on the same in Python. Let's see what a double-ended queue is. A queue normally works in a fashion where the data is allowed to be inserted at the rear end, whereas the data will be removed from the front end. The intermediate data is not allowed to access, right? The person who is using the queues as a data structure or to store the data cannot access the data which is inside except the data at the rear end as well as the front end. It is a linear data structure. The basic drawback of a double or the basic queue is, suppose let's take an example of a queue in this manner. The data is filled, say the index values are 0, 1, 2, 3, 4, 5. Says it is having a space of 6 elements and the front is pointing at the third index value. The elements stored are A, B and C, and as usual the rear is pointing to the element the last, which is most recently inserted, which is C, right? So as the rear is pointing to the last element and the overflow condition, the condition which says that you cannot further insert an element into your queue is R is equal to n minus 1, where n minus 1 is the largest index or the highest index of the queue, allocated queue. Even though we have empty spaces, we cannot insert the element. That is the basic drawback of a linear queue or a basic queue. To overcome that, we have come up with double-ended queues. So it is a queue where there is no restriction of insertion and deletion. As the front end is specified for deletion, in a double-ended queue, we can even insert the data at the front end. Whereas rear end is normally used to insert the data, whereas in double-ended queue, even we can delete the data at the rear end, right? It is often known as head-tail linked list, right? So, and it is used and it is implemented using circular queues. Okay, basically it will be circular in nature. What does it mean is the last node will be pointing to the first node, right? Let's have a look at this picture. Double-ended queues, as I have shown, deletion and insertion are possible at the front as well as the rear ends, right? So the basic operations that we can perform on in double-ended queue is we can insert at the front as well as the rear ends. We can delete at the front as well as the rear ends. We can see what are the elements that are present at the front end as well as the rear end, and even we can check whether the queue is empty or full. So these are the basic operations that we can perform on any double-ended queue. So let's look into these operations with the small animation. Okay, so basically when we call a queue to be empty, whether it is a circular queue, double-ended queue or a linear queue, the basic funda is the same. It says that if the front and rear are having the basic default value which is -1, indicates that the queue is empty, right? So this is the case where the queue is empty. I have taken 6 spaces, 6 contiguous memory locations which are going to act like a double-ended queue. Initially, the front and rear are initialized as -1. With the first insertion, right? The first insertion will be either you take the option of insertion at the front or the rear. Both the cases will be one and the same. Why? Because when you insert an element, very first element into the queue, as front and rear are having the default values -1, both will be incremented. So there is no point in saying whether you are inserting at the front end or at the rear end. So either one of the cases you can choose. So as soon as I insert an element into the queue, double-ended queue, the front and rear will be incremented. Now front and rear are pointing to the index value 0. Right. Then you can see that I have highlighted what will happen if front and rear, either one of them is having -1, then both will be incremented and they'll get the index value 0. Now, from here, inserting a different and a rear are two different cases which we need to address. Okay, what if you want to insert element 16 at the rear end? Simply increment rear so that it is going to point to the new index value 1 and insert the value. What if you want to again insert an element at the rear end only? So very simple, increment the rear. Now rear is pointing to index value 2, insert the element into the index value 2. So now you can see that Q is in this fashion. Its front end is holding a value 6, whereas its rear end is holding a value 32, right? So next, again an insertion at the rear end, 54, incrementing the rear end, you are going to insert the value, new value. What if you want to insert a value at the front end? So front end is pointing to the least index value, that is index value 0. What to do now? As it is pointing to the least index value 0, and even I have said that double-ended queues are basically circular in nature. That is, you can traverse from the highest index value to the 0th index value, right? There is a relation between them. There is a connection between them. So if f is equal to 0 and if f of f, or you can say that if the max position is vacant. Yes, it is vacant. How can you know that if R is not pointing to the maximum index, right? If R is not pointing to the maximum index, then you can easily say that that place is vacant. So make the front move in a circular fashion and reach the highest index value where the slot is empty. Now insert the new value into that index, right? Which is 61. Right? Next case, what if you want to insert an element at the front end? Remember, guys, whenever we try to insert an element at the rear end, we incremented the rear end, right? The reverse is going to work for front. So front, if you want to insert, you need to decrement the front, right? So let's look at that once, right? So decrement the front and insert a value into the queue, right? Double-ended queue, DQ, right? So I have decremented it. Now you can see a condition over here. The index value that the front points to, that is the value of f, is equal to r plus 1. This is the condition which tells you that the queue is full. The queue is full. Have a look at this small explanation. The index value of R is 3 plus 1, which is 4, which is nothing but F, the index value which the front is pointing to. So we can say that the queue is full. This is one of the conditions which say that the queue is full. If you try to insert an element now, then it will go to overflow condition. Overflow condition is a condition which says that as the queue is full, we cannot insert an element into it, right? So let's look at few delete operations. So deleting at the front is the new one. Basically, right? So now here have a look at this one. The front is pointing to index value 4. The basic job of front is to delete an element. How we delete an element? By simply incrementing the front. Do the same. Increment the front and the element will be deleted. Because now the friend is pointing to the next index value, which is 60, right? So again delete an element. As my friend is pointing to max minus 1, that is the maximum index value, I'm going to bring it back to index value 0, right? So as previously it was pointing to the highest index value, which is 5. So to remove an element at the front end, I have to bring it back to 0. What does this mean is, whenever you delete an element at the front end, just have a check whether your front is pointing to max minus 1 or not, which is highest index value or not. If it is pointing to highest index value, make it 0, or else just increment the value of the front. Job is done, right? So next, deleting at the rear end, right? Have to delete an element at the rear end. Rear end is usually meant to insert the data, right? In a basic queue or a linear queue, we used rear end to insert the data. Now the special purpose is to delete the data, right? So to insert at the rear end, we increment it. Now to delete, we decrement it. We decrement it, and as I have decremented, now my rear end is pointing to the element 32, right? Element 32. Now again deleting an element at the front. Actually my front is pointing to index value 0. Simply increment it, delete it. What if I insert an element at the rear end? Random options I have taken my use. Okay, so simply increment rear and insert. So when you keep on inserting, this is the case, right? So this is another case where you can say that the queue is full. The case is a case where your front is equal to 0 and rear is pointing to max minus 1, right? Have a look. So front is pointing to 0 and rear is pointing to max minus 1. And this is one of the condition which says that the queue is full. Previously we have seen that if f is equal to rear plus 1, if either one of these conditions prevail, then we can say that the queue is full, right? So now what if we delete an element at the front? Simply by increment front money, by decrementing it, we do it, right? Again delete, again inserting at the rear, and these are these random operations which I have used, guys. So my rear was pointing to the last element. So to insert an element at the rear end, first of all I have to check whether the index value is the front is pointing to 0 or not. If it is not pointing to 0, we can make rear to point 0 and insert the element, right? So let's see this last option, which is deletion at the rear. Okay, rear is pointing to 0. What will happen if you delete an element at rear? So before deleting at the rear, you have to look for the condition whether it is pointing to 0. If it is pointing to 0, make it max minus 1, right? I hope you have seen this. So as rear was pointing to 0, I made rear to point to max minus 1, that is the last index. As double-ended queue will be circular in fashion. Okay, this was the small demo of how a double-ended queue works. Let's see the implementation of the same with the help of a small Python program. Okay guys, let's look at a program on double-ended queues. Right, so double-ended queues, this is the implementation of double-ended queues. Let me give that a heading. Implementation of double-ended queues. So I want to make a menu-driven program because I have many options. So inserting at the rear end, front end, deletion at the rear end, front end, and the display and all. So a minimum of 5 functions I can have. A minimum basic double-ended queue I want to implement. So I want to write a menu-driven program for the same. So let me write the driver code first. Okay, the driver code goes with the, first of all, I'm going to take the size of the queue, the maximum size of the queue. I'm going to read it. Enter the number of elements. Right. So once I enter the number of elements, I'm going to take an array which is going to act like a queue in my process. Right. Then initially I'm going to take the default values of front and rear as -1. Okay. Then I have taken the maximum limit. I have taken a blank queue, and I've taken the pointers which are going to point to the front and rear ends, and their basic default values are -1. Right? Then, what will be my menu? That is the primary question. Guys, I'd like to go with a beautiful menu. First one, the first option is insert at the rear end. Right? That is a default expression that I have. Second one is insert at the front end, which is a new one which have come up in double-ended queues, which was actually not there in linear queues. /n 3 dot. Third option will be delete at front. This is a normal operation, deleting at the front end. Then delete at the rear end, right? And a normal basic display function which I would like to have, right? Display, right? So this is going to help me to display. So let's do one thing, guys. With every insertion or deletion, it is going to show me the partial outputs. So I'm going to make display as a part and parcel of my each and every function. I'm going to call it all. So exit. So if you press 5, you're going to exit, right? So let's do the same, guys. Yes, this is my menu which I've designed just now. Now I'm going to start with my choice, which is by default 1. I'm going to, I don't know how many times I'm going to run this loop. So I'm going to use a while loop. So unless I give an option 5 to it, I'm going to run it, right? So let's start it. First of all, I have to read a choice, right? To start, int of input, enter your choice. So once you are going to enter your choice, let's take or call each and every function with the corresponding choice value. So if choice is equal to 1, what is this first option which I have taken? To insert at the rear end, right? Insert at the rear end. This is the function which I'm going to call, and the things which I'm going to pass to it is the array or the queue. Let's take this, the queue in which it is supposed to insert, and a value I need to pass. So I'm going to read it here itself. Input, enter an element. So yeah, this is my if condition where I'm going to insert. I have chosen insert at the rear. Okay, once I insert it, my job is done. What if my choice is equal to the second choice, which says insert at the front end. Insert at the front end. Even while inserting at the front end, also I have to pass basic two parameters. One is the queue which I am considering, and second argument will be the element which I want to insert. Right? So enter an element. Guys, these are user-friendly statements. The statement which I have given, enter an element, enter your choice. All these are user-friendly statements. You can modify it as per your wish. The third option will be I think now I have closed. Elif, if my choice is 3, which says that, so what is the third option? Delete at the front. I'm going to call that function. So for that function, nothing is needed to pass, only the queue from which you want to delete. Just the element at that particular position will be removed. So no need to read any element or nothing like that. Okay, then next, elif, if my choice is 4, then delete at the rear end. Even for that, I just need the queue, the name of the queue, that is it. So what if any other case you are thinking of, then, or somebody may print any random value, any character, right? So for that, I'll give a user-friendly statement, have to use it. Okay, so enter a proper choice or press 5 to exit. So explicitly I am advising them to do either one, right? So this is how I'm written my basic, the driver code which I want to show, right? So then we have fill this I have to fill this driver code with the function calls. So if with each and every function call, a function is supposed to raise, and I have to fill it. Let's start the same. Right. Def. The first and foremost function that we are going to see is insert rare. So I have used capital I. Please guys, be sure Python is case sensitive. It differentiates between uppercase as well as the lowercase. So be careful. I've used I and to delete D as caps, right? So I'm going to use the same. So I'm going to take 2 arguments. This function is going to take 2 arguments. Then have to do it. First of all, I'm going to declare my front and rear to be global parameters. Why I'm taking them as global parameters is whatever due to insertion, the positions of the front or rear are going to change, right? So when you go to during process, if when your cursor moves from or your point of concentration moves from one function to the other function, you need to have the latest values of the front and rear in your hands, right? So global is the keyword which is used to make the rear and front values keep on updating, and universally wherever front and rear are used, they are going to get the latest values. So for that purpose, I'm declaring them as rear and front as global initially. That is my primary job, right? Next, if my front is equal to rear, okay, so this is one of the conditions when front is equal to rear. And the second one is What if R is equal to N minus 1? Guys, we have to check whether insertion is possible or not. So before going to that, I need to check whether the queue is having some empty space or not, right? So while showing the animation, what are the two conditions which I have shown you? A case where my front is pointing to 0 and the rear is pointing to the maximum index value, or the case where front is ahead of rear. If either one of these conditions gets satisfied, then I'm going to print overflow saying that the queue is full and I can no longer insert an element, and then simply return, because insertion is not possible. If this is not the case, there is some empty space, then I need to check what if rear is pointing to minus 1. That means what do you mean by rear is pointing to minus 1? Very simple. The queue is empty. This is the case where the queue is empty. So if the queue is empty, what you're supposed to do? We have to make the front and rear both as zeros. We have to increment both of them, the new positions, right? This is one case. Other case, a case where queue is there which is not full, and even rear is not pointing to minus 1. That is, the queue elements are there. It is not empty also. It is neither empty nor full case, guys. So in that case, you will have two conditions. If your rear is pointing to, the highest index value. So if the rear is pointing to the highest index value, what you have to do? You have to make it point to 0. Right? This is one case. Then the next case is a normal case, ordinary case. Rear is somewhere in between. And how to insert? Simply increment the rear. Right? So these are all the cases where we are going to insert an element at the rear. Okay? So we have covered all the cases. Now the insert operation. The name of the queue dot insert at the rear end and the element which I want to insert. This is the inbuilt function which is already present in my Python libraries which I'm using, insert function. Then I would like to display how it looks like after inserting at the rear end, how it looks like, my queue looks like. So I'll be writing a function for the same. You need not worry about that. I'll write it. Okay. So the next function is insert at the front end. So this is a new case. We always delete an element at the front end. But in double-ended queue, I would like to insert an element at the front end also. Right? So the basic parameters which are meant for it are A and item, that is the queue and the item. Then similarly, the global declaration of rear, front, right? Then I'm going to check if front is 0 and rear is equal to n minus 1, which says that the queue is full, or there can be a case where f is equal to r plus 1. Even this case tells that the queue is full, right? Then in both the cases, I'll simply write overflow and I quit, or I say I can return. I'm going to return. What if it is not the case? Empty space is there. Then I'm going to check. Is this the first element which I'm inserting? If my f front is pointing to minus 1, guys, it's not that I'm using front. You can even use rear. If front is pointing to minus 1, then definitely even rear will be pointing to minus 1. Okay, right. So as front is, if front is pointing to minus 1, I have to change the positions of both front and rear together, right? So this is one case. Else, a case where if front is equal to 0, what will we do? If front is pointing to 0, you have to make it point to the last element, right? F is equal to N minus 1, right? Or else the ordinary case. What did I tell you? To insert an element at the front end, we need to decrement it. F is equal to F minus 1, right? I have decremented it. So these are all the cases which are involved in inserting an element at the front end. So as I have covered all, now I'll write the function 2, or I'll use my inbuilt function insert. So it needs two parameters. One is the position and the second is the element which you want to insert. So F here, F is the position and item is the element which I need to insert, right? Once I do that, I'm going to display it. Yeah. There ends my job of inserting at the front end. Now let's look at into deletion operations. Deletion at the front is the normal one and deletion at the rear is the added feature, right? So let's start with the existing one, which is deletion at the front end. Def delete at the front. As I said, to delete, we need not pass any element other than the name of the queue. Just by specifying which element you want to remove, whether the front element or the element, the job is done. We do not specify which element we want to delete. We don't have access to the intermediate elements, right? So either you can delete an element at the front or the rear. By just specifying F or R, job is done. We do not specify any element, right? So even my deletion operations are going to change the values of or the pointers of rear and front. So I'm passing them as global so that I can get the latest value and I can update them for global purpose, right? So what if front is equal to minus 1? What do you mean by this? Which means that the queue is empty in nature. So I'm going to print underflow and I'm going to return, right? As deletion operation is not possible, right? Else, a case where it is possible, then I'm going to store the element pointed at the front end because I have to remove the element at the front end, right? In F, and I'm going to just display it saying that this is the element which I want to, which I have deleted, okay, at the end. Okay, I've stored it. Now let me look at the cases. Are F and front and rear pointing to the same element? Are they holding the same index value? When will this happen? This will happen when you are trying to delete the only element present in the queue. Only element. Its position can be between 0 to max minus 1 anywhere, including the boundaries, right? So it can be anywhere. If front and rear are pointing to the same element, it means that this is the only element left in the queue. What does that mean? If you remove that, the queue becomes empty. If the queue becomes empty, what should be the new positions of front and rear? They should be back to minus 1, right? So that's what I'm trying to do now. So I'll make front, rear point to minus 1, right guys? So what if this is not the case? If this is not the case, then what if my front is equal to n minus 1? That means front is pointing to the last element. If you delete the last element, to which location it is supposed to point to? It is supposed to point to the 0th index, right? So an ordinary case, a normal case. In general, in normal case, when we delete an element at the front end, we simply increment it. We simply increment it. I incremented it. Now I'd like to go for a print statement saying element deleted is %d %item. This is a small display statement, user-friendly display statement to just show that what is the element which I have deleted. And followed by, I would like to see the current position of the queue. So I have called the queue once again. Okay, this is as a whole the deletion function at the front. Now let's look at a new function, deletion at the rear end, which needs only the queue as the parameter. Even here I have to pass the front and the rear as the global parameters. If rear is pointing to -1, which says that the queue is empty, I'm just going to print underflow and I'll return. Okay, then what if front is equal to rear? The normal case, which we have already seen in case of deletion at the front, that is the only element that is present. Then I have to make my front and rear point to the default values, which is -1, right? Else, a normal case. In the normal case, if R is pointing to 0th index value. So when you delete an element which is pointed at the 0th index value, in the case of rear, we have to make the rear point to the max element, which is n-1, right? Then an ordinary case where nothing is like that rear is not at a 0th location, and even it is not the only element, and the queue is having a handful of elements, then rear is decremented. Remember guys, rear is decremented to delete an element at the rear end. In case of front, we have to increment front. In case of deletion, we have to rear end, we have to decrement it. We have to decrement the position, right? Similarly, as I have done with the front end case, after deletion, I have printed what is the element that I have deleted. The same user-friendly statement I am going to repeat over here. Element deleted is %d %item. Right? So this is a user-friendly statement to show. Yes, again I'm going to see the current status. Right? So the basic 4 functions: insertion at the rear end, insertion at the front end, deletion at the front end, deletion at the rear end are over. But you can see that repeatedly at each and every stage, I'm trying to see what is the current status of my queue. To do that, to come that, to fulfill the task, I have to write a function to display, right? Let's write a function to display. To display, I just need the queue, nothing more than that. I'm going to retrieve the latest values of front and rear, right? Then I'll use a new line also. Current status of queue is. Okay, it's just normal user-friendly statement. So I have to be very cautious. I need to fulfill the prerequisites also. A case where If my front is pointing to -1, then the queue will be empty. Nothing to display out there, right? So even that case I have to cover. If it is equal to -1, then I'm going to print that queue is empty, and I'll return because there is nothing to print, right? Now here in the display is not that easy, guys. There are two cases. There will be a case where front and rear will be pointing to the same element, or the index value of rear is greater than front, or the index value of rear is lesser than front. We have to cover all these cases, guys. So let's have a look at this one. What if rear is greater than or equal to front? If this is the scenario, then for I in range of start from front to the rear, you know that in the range function, the second parameter will be the stopping parameter. As I have to travel from front to rear, I'm taking +1, that will be the stopping criteria. Once it crosses the boundary of the rear, it is going to come out of the loop. Okay, then print A of I. So with the small spacing, guys, space between the values. So I have taken the end, right? So else, here I have covered two cases. What if the value of rear is greater than f or equal to f? What if it is lesser? This is the scenario. So I have to, that means the list is divided into two pieces, equal or unequal, but two pieces it is divided. I need to cover both. So for I in range of f plus 1 to n plus 1, that is till the last, I have to go. So print A of I, n is equal to, this is the right side half, you can say. What about the left side? Range of from 0 to r plus 1. Right? So print A of I, n is equal to, yes. Right? So with this, I end my display function also. Let me take it with the name .python file. Right, guys? So have a look at this one. We have covered, let's have a look whether we have covered all or not. Let's go through our driver code. We have read the maximum size, which is n. I have taken an empty list A, which is going to act like my queue. I have initialized the front and rear with its default values as -1. And I have taken a user-friendly statement which will be displayed when I execute it, right? Then basic initialization of choice I have taken as 1, which I'm not going to use. Okay, so just to enter the while loop. And I've seen and I have written a if else ladder in such a way that with every choice, with each and every choice, a function will be called. And if you press 5, you're going to exit. Okay, then coming to the functions. So I've written the function to insert at the rear end, the front end, and deletion at the front end and at the rear end. So these are the functions, and with the help of a display function, we can see the current status of the queue at each and every point. Okay, so enter the number of elements. Say, let me take the maximum size as 5. So this is the menu which I got. Insert at the rear end, at the front end, delete at the front, delete at the rear, and 5 to exit. Let me insert at the rear end. First, which is my choice, and the element is 21. So the current status is 21. Right, guys? And again, I want to insert an element at the front end only, and the element is 22. This is the current status, 21 and 22. The rear is incremented. Initially, the rear and front both were pointing to 21. Now the rear is incremented and the element is inserted at the next location, which is 22. With this, I'd like to conclude the execution of double-ended queues. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.